Hello everyone, I am Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to solve some problems on power switching devices, that is first module. In this first module, total 10 questions. So problem solving and critical thinking questions. So first one is make use of gate triggering technique to find the gate source resistance of SCR with gate cathode characteristics has a straight line slope of 130 and a triggering source of 15 volts. And next, allowable gate power dissipation of 0.5 watts. So now, solution for this one, the given data first here, this allowable, gate power dissipation is 0.5 and triggering source voltage is 15. And next here, slope Vg by Ig is 130. So now here, if you see the Vg into Ig, this allowable gate power dissipation is 0.5. Now here next one, Vg by Ig is the slope, so that is 130. So now we have two equation 1 and equation number 2. From these two equations, you can solve this Ig and Vg. So now here, this Ig, Vg equals to 130 into Ig, substitute this Vg equals to 130 into Ig, 130 I square G equals to 130 Ig into Ig, that equals to 0.5. So from this you can determine this Ig equals to 0.062 amperes, that is 62 milliamperes. And after that, from this 0.062 Ig value, you can determine the Vg value, that Vg value equals to 8.6 volts. So now we have determined this Ig and Vg. So now here, so what about this gate recurring voltage here? So this voltage is 15 volts. So here, this voltage is, find out the gate source resistance here. So not Ig and Vg. Gate source resistance means this one. This RS you need to determine. So we know this, if you apply KVL in this loop, if you apply KVL in this, Vs equals to RS into Ig plus Vg. So now RS into Ig plus Vg equals to Vs if you apply KVL in this loop. Now here Vs equals to 15 volts and Vg equals to 8.06, and next Ig value is 0.062. So now here you can apply V15 equals to 8.06 plus 0.062 into RS. From this you can determine RS value. RS equals to 111.94 ohms. So this is the find out the gate source resistance. So here to determine this one, we need you need to remember, keep it in mind. So this formula, this KVL equation, and this is the slope Vg by Ig. This Vg by Ig is the slope if you draw the gate current characteristic, gate cathode characteristics, and this is the allowable gate power dissipation. If you know this, you can solve this problem easily. And next, second problem here in this. So the triggering circuit of thyristor has a source voltage 15 volts, means that is Vs equals to 15 volts. The load line has a slope of 120 volts and volts per ampere. And next, the minimum gate current to turn on SCR is 25 milliamperes. So determine the source resistance required in the gate circuit and the triggering voltage and triggering current for the average gate power dissipation of 0.8 watts, 0.4 watts. So now here, in the question itself, this is the slope. The slope is the source resistance required in the gate circuit. So that is 120 volt per ampere. This is the 120 ohms is the source resistance required in the gate circuit. So now here solution for this first question is over 120 RS equals to 120, and next here VG into IG. So already we have seen this VG into IG, that allowable gate average gate power dissipation 0.4 watts. And next here this is the circuit diagram. So in this circuit diagram, this is actual gate, anode, cathode, and this is gate. So here if you give the gate current, gate anode to cathode, gate cathode power. So here this is a RS value is 120 here, and next this is IG and VG. How you will calculate the IG and VG? Here this is gate current, minimum gate current here. So this Vs equals to 15 volts, and next here Vg equals to Vg, you can here in the Vg, and Rs equals to 120. So now here this Rs equals to 120, and here Vg this Vg equals to 0.4 by Ig. So this is Vg, and next Ig as it is, and 15. So now if you solve this equation, so here this is the 120 Ig square, 120 Ig square plus 0.4 plus 15 Ig. If you solve this, you will get the Ig value equals to 38.56, and next that is milliampere, and 86.44 milliamperes. So now this is Ig only. So now that is triggering current. So what about the triggering voltage? From this you can determine the 0.4 by Ig, that equals to this value equals to 0.4 by 38.56, that value equals to 10.37, and or another one here 0.4 by 86.04, that equals to 4.62. So here we have two values. So now here third question, a SCR has half surge rating of 30 amperes per 50 Hz supply. Calculate its 1 cycle surge current rating and I square T rating. So now here solution for this, the given data here, surge off cycle surge current rating is 3000 amperes and frequency equals to now here this is, we know this formula, this is ISB is sub cycle surge current rating, and this one is the half cycle surge current rating time period. And now here this T equals to, here time period T equals to 1 by 50, that equals to 20 milliamperes. So now this T equals to 10 milliamperes. So now here I square equals to ISB square T by T. This equals 20 and this one is equal to 10. So now here 3000 square into 10 by 20. So now here this I square equals to this I equals to 4500. Fourth question, SCRs with a rating of 1000 and 200 amperes are available to be used in the string to handle 6 kVA, 6000 volts and 1 kVA, 1000 ampere. Calculate the number of series units and parallel units in case the rating factor is 0.1 and the rating factor is 0.2. Here SCR number of SCRs are connected in series to increase the voltage rating, and SCRs are connected in parallel to increase the current rating. So now here in this, how many number of SCRs connected? So to increase this is actual SCR rating, and to increase this voltage, so SCRs are connected in series. So now here this is the actual current rating of SCR, and to increase the current ratings, this much amount of current rating. So how many number of SCRs are connected in parallel? So that is the question. for that case, derating factor is 0.1 first case and second case is 0.2 for second case. So now calculate. So given data, solution, and now here what is the formula here for series case? So now the series case, so the derating factor equals 1 minus Vs by N into Vd1 into 100. So now it is in the percentage. So now here 0.1 equals to 1 minus 6000 is not required, I think. Now 6000 by 6000 into 1000. This 1000 volts and 6000 volts. So this is Vs, and next this is a Vd1. So now here from this you can determine the N value equals to 6.66, that means almost 7. So now number of series SCRs connected in the string. So 1000 ohms SCRs to increase the voltage rating up to 6000 volts. So there are 7 number of series units. For that case, that is 0.1. If it is the derating factor 0.2 for that case, so that value equals to 7.5, means almost 8 number of series SCRs. So now for parallel case, so parallel units, so same formula but here current. So this total current is Is and this is the ID1. So now in this case same 0.1, this 1000 divided by 200. So this is not required. This one also. So now here this is this one 5.55, that means almost 6. And next for 0.2 case, so that value equals 1000 by 2000, 0.2. So for this case that value equals 6.25, means almost 7 number of SCRs are connected in parallel to handle the 1 kilo ampere. Now next case, it is required to operate 250 amperes SCR in parallel with 350 amperes SCRs with their respective on-state voltage drops of 1.6 and 1.2 volts. Calculate the value of resistance to be inserted in series with the SCR so that the total load of current is 600 amperes. So in proportion to their current ratings. So now if you see the solution and given data, so this is the circuit diagram, actual diagram. So two SCRs are connected in parallel. Actual case, this is T1 and this is T2. This is two SCRs are connected to increase the voltage. So in the first case, this current is 250 amperes and this current is 350 amperes. So now here this rating voltage, on-state voltage drops 1.6 and this on-state voltage is 1.2. So now here the dynamic resistance of first resistance is, so first thyristor 250 amp thyristor, that is SCR is, so total 1.6 voltage divided by 250, and next second dynamic resistance of this 350 amps SCR T2 is 1.2 by 350. So now here we are inserting some resistance here, some amount of resistance in series with each SCR, so that the total share of current is, that is 600 amperes. So now here in proportion to their current rating. So how you will calculate? We know the current division formula, total current into opposite branch resistance divided by total resistance. So here this is the resistance. So this R1 equals to this 1.6 divided by 250 and this R2 equals to 1.2 divided by 350. So we have two resistors are connected in parallel. So this R plus this resistance, R plus this resistance, two resistors are connected in parallel and we have total current. So from this you can determine the individual currents. This current, when same amount of resistance connected in series with each SCR, this R you need to calculate here. So how you will calculate? So same current division formula. So now here that what about the current division formula? So now here this is this resistance equals to, first this branch resistance equals to total resistance, this I1 current, this I2 current. So first current I1 current equals to this current I1 current equals to first one, that means 250 amps current. So now here this current equals to total current 600 amperes into opposite branch resistance 350. So opposite branch resistance means 1.2 by 350 plus R divided by, so now total resistance 1.2 350 plus R plus 1.2 1.6 250 plus R, so that equals to 250. And same way, similarly, this is equation number 1. In this equation number 2 indicates same thing, I2 equals to that means 350 amperes. So now opposite branch resistance equals to opposite, what about the opposite branch, 600 amperes total current into opposite branch resistance means 1.6 by 250 plus R divided by 250 plus 1.6 by 250 plus R plus 1.2 by 350 plus R. So now here this is equation number 2. If you do 1 by 2, if you calculate 1 by 2, this denominator is same, and that one equals to, that value equals to 250 by 350, that equals to 250 by 250 and 1.2 by 350 plus R and 1.6 by 250 plus R. So from this you can determine the R value, that R value equals to 0.004 ohms. So in this way we can calculate the value of resistance to become inserted in the series with each SCR. So now here, sixth problem. So SCRs with a rating of 1500 volts and 100 amperes are available to be used in the string to handle 6.6 volts. Calculate the number of series units required if derating factor is 0.2. So the given data, solution, and so already we know this formula, this 0. Percentage derating factor 1 minus Vs by N into Vd1 into 100. So now if you substitute, this derating factor is 0.2 and this is 6.600 and this is a 1500. So from this here you can determine this number of series units are connected. So that value equals to 5.55. That means almost 6 number of series SCRs to handle this 6.6 with the rating of 5 number of SCRs. Next, this problem is most important. Now here class B commutation. So class B commutation, in the class B commutation, so there is a capacitor and there is an inductor. So capacitor value is 20 microfarad and inductor value L equals to 5 microfarad, and initial voltage across the capacitor is, so now there are assumptions, load current is constant and initial voltage is supply voltage, that capacitor voltage is supply voltage, and LC circuit is resonating in the nature. So now Vs equals to 230 volts for constant load current is 300 amperes. So now calculate the conduction time for auxiliary thyristor TA and voltage across the main thyristor when it gets commutated and the turn off time for main thyristor. So the given data and solution. So the circuit diagram for class B commutation. This is the main thyristor. This thyristor is to be turned off by using this external circuit. So now this is the supply voltage and this is the load actual circuit. This is the forced commutation, means class B commutation. So external component is required to turn off this Vs. So that external components are here. This is one auxiliary thyristor. This is LC circuit L and C, and this is one diode D, and this is the load current. So this is the load current I0. So now load current I naught equals to 300 amperes. So 300 amperes. Now the supply voltage equals to 230 volts, and this L equals to 5 microhenries, and the C equals to 2. The C equals to 20 microfarads. Okay. Now here, so what is the conduction time for auxiliary thyristor? There is a formula. So conduction time for this auxiliary thyristor TA equals to pi by omega. So pi by, not this one. So pi by omega naught, that equals to pi into square root of so this is wrong. So actually pi by omega naught, that equals to pi by 1 by square root of LC, that equals to pi into square root of LC, not 1 by root LC. That value equals to, so 3.14 square root of 20 into 10 power minus 6 and into 5 into 10 power minus 6. If you do this, you will get the value 31.46 microseconds. So not in the denominator, in the numerator only. So this is the conduction time for auxiliary thyristor. So conduction time. So how much time? So the auxiliary thyristor is in the on. So now here voltage across the main thyristor. Voltage across this main thyristor is, if suppose it is VAB, so that VAB equals to Vs into cos phi, Vs into cos phi. But how we will calculate this cos phi? So now here I naught by IP. What do you mean by I naught? I naught is the load current. So what about the I peak value? Peak value of current. So now that value equals to main thyristor peak value. So this Vs by square root of C by LC. So now if you do this calculation, so now this is 230 into square root of 20 into 10 power minus 6 by 5 into 10 power minus 6. If you do the calculation, that value equals to 460 amperes. So now here this sign, this from this you can determine the phi value. So sine inverse, so this 300 divided by 460, so that value equals to here 40.7. So this Vs equals to 230. So this Vs equals to 230 into cos of 40.7. So now if you do this, and the value is VAB equals to, so 174.355 volts. So this is in the degrees. So now the voltage across the main thyristor is 174.355 volts. So next, circuit turn off time. Circuit turn off time equals to voltage across the main thyristor, this capacitor value, and load current. So this equals to C equals to 20 into 10 power minus 6 and 174.355 divided by, and next this is 300. So the value of this one is 11.624 microseconds. So this is simple if you know the circuit diagram and if you know the formulas for conduction time. So the pi into root LC, not this one, and VAB equals to cos phi, phi equals to sine inverse I naught by IP, and IP equals Vs by square root of L, C by L. And next thing here, this is the circuit turn off time. This is most important. T equals to C into VAB by I naught. So now in the next problem, class C commutation, 8th problem. So class C commutation, in this supply voltage equals to 200 volts. In that there are two resistors we will use to turn off the SCRs. So it is a complementary commutation technique. So R1 and R2, that R1 equals to 10 and R2 equals to 100 ohms. Calculate the peak value of current through SCRs T1 and T2. So the value of capacitor C, if each thyristor has turn off time is 10 microseconds. So take the factor of safety factor is 2 now. Here solution for this one and given data. So given data, this R1 equals to 10 ohm and this R2 equals to 100 ohms, and here you need to calculate here this capacitor value, what is the value, and next circuit only capacitor value, and next here this supply voltage equals to 200. This is the type C, class C commutation or complementary commutation process. So now here to turn off this T1, so we are using this external circuit, that is forced commutation technique. So to turn off this T2 SCR, this technique we are using. So now here this is the forced commutation technique for external components. So to turn off T2, T1 and T2 are complementary fashion, they are terminating each one. So this is 210 and 10. From this you can calculate the capacitor value. So what is the value of capacitor value? So first here you need to calculate the peak value of current through the T1 and T2. So this IT1 and this is the IT2, and for the peak value. So what is the formula? First one, so IT1 equals to this supply voltage into 1 by R1 plus 2 by R2. So what is the formula? If you do this, if you substitute in this case, this is 10, this is 100, this is 230. So if you calculate, is that value equals to 24 ampere. And next one, IT2 equals to 2 by R1 plus R2. So now IT2 equals to, that value equals to 42 amperes. So now here C value, this peak value of IT1 and IT2 calculation over. So only you need to remember these two formulas. IT1 equals to Vs by 1 by R1 plus 2 by R2. And next here IT1 equals to, this is IT1 and this is a IT2, sorry, this is IT2. So now here this one here, this IT2 equals to 42 ampere. So now this, what about the capacitor value? Capacitor value equals C equals to T by R1 ln 2, that equals to this one. So now T equals to, this turn off time equals to 40 microseconds. So 40 into 10 power minus 6 divided by R1 is 10, and next here ln 2. So that value equals to 11.53 capacitor value. So now next case, second one also you can calculate. So second R1, that value equals, if you substitute 100, that value equals to 1.153. So in the complementary commutation circuit, that means class C commutation technique, load resistance R1 and R2 10 ohms and C value. So now here the supply voltage is 100 and determine the circuit turn off time. So now this one R1 is 10 and R2 is 10. This is the 10 microfarad and this is the 100. So we know the formula. So C equals to T by R1 R2, or R1 R2 is same, means you can use any formula. So now if you substitute T equals to, this turn off time T equals to C into R1 and ln 2, T equals to C into R1 into ln 2, C equals to 10 into 10 power minus 6, and next 10 into ln 2. So that value equals to here 6.93 microseconds. So now here the last question in this module, the SCRs with a rating 200 volts 100 amperes are available to be used in a string to handle 12 volts and 2 kVA. Calculate the number of parallel units required if the derating factor is 0.2. So already we solved the similar problem. So for parallel circuit I am taking here. So percentage D equals to 1 minus Is divided by N into I D1 into 100. So now here 0.2 1 200 by this 2000 divided by 100. So now here this value equals to 25. Here 25 a number of parallel units are parallel SCRs are required to handle 2000 amperes SCRs. So here 100 ampere SCRs. Total 25 number of SCRs, 100 ampere SCRs are required to handle 2000 ampere. I hope all these 10 questions, 10 problems are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.